This is another example from 4.7 part 2, and we are talking about properties of trig inverses. Now in the previous video we talked about trig inverses where the order was different. Here we're going to start with the inverse function followed by the regular. And so the order in which these things come is really important. Now in the previous one where the order was flipped, it was true for everything as long as they were defined. However, on these ones, when you put the inverse trig function on the outside, or when that comes first, that is going to, we're going to have to be a little bit more careful about that. It says true on restricted domains, so we'll think about that as we go along here. So the true unrestricted domains, so in general, like before, sine inverse and sine undo each other. And same with all the other ones. So that's the concept here, but we just have to make sure that everything works out. Now, I want to just point your attention to the angle that's going on inside each one of these things. We have to be certain that this is true unrestricted domains, but we're actually going to be paying attention to the range of the sine, tangent, cosine, sine inverses. Now, if you'll remember, we talked about domain and range. For sine inverse and tangent inverse, we had to make sure that whatever came out was in either quadrant 1 or 4. That's for sine, and it's also for tangent inverse. For cosine inverse, it was quadrants 1 and 2. So we just need to be very careful about those as we're going through and working on these problems. We look at each of these angles and we decide, first of all, what quadrant is it in? If it lies within one of the quadrants that's listed in the range, then we're good to go. If it doesn't, that's where we have to take a closer look. So I'm just going to start by going through and labeling these quadrants. Pi over 3 is in quadrant 1. Negative pi over 4 is in quadrant 4. 5 pi over 4 is in quadrant 3. And then 2 pi over 3 is in quadrant 2. So we got a little bit from each. All right, so here's the process that we go through. We see sine inverse of sine of pi over 3. We notice that this angle is in quadrant 1. So we have to ask ourselves, is quadrant 1 a part of the range of sine inverse? And it is. It's either 1 or 4. This one is good to go, and we can just say they undo each other. This is pi over 3. Next up is tangent inverse of tangent of negative pi over 4. We determined that that was in quadrant 4. Is that in the range of tangent inverse? Yes, it is. Quadrant 4 works. And so again, this one is just they undo each other. So we've got pi over 3 and negative pi over 4 for those. Pretty simple. Here's where we run into some troubles in 3 and 4. We have cosine inverse of cosine of 5 pi over 4. Now, right away, if you see 3, that's going to be a red flag because the range of none of these has 3. So we know that cosine inverse does not contain quadrant 3. If that's the case, we have to do a little bit different method here, and that is going back to our compositions from 4.7 part 1. It's not a huge thing, it's just that we now have to do these two pieces individually. So cosine of 5 pi over 4. I'm going to draw a picture for that up here. That's in quadrant 3. And so 5 pi over 4 is a 45-degree angle. That's coming down here. Place that in quadrant 3, and it is going to be negative square root of 2 over 2, negative square root of 2 over 2, and 1. So we want to know what is the cosine of this setup right here. All right, well, cosine of that setup is going to be adjacent over hypotenuse, and so I'm going to replace this cosine of 5 pi over 4 with negative square root of 2 over 2. So I'm going to rewrite this as cosine inverse of negative square root of 2 over 2. All right, now that I have this, this becomes just basically evaluating an inverse trig function. We have to make sure we get the right quadrant and also the right triangle. Now we know the triangle already. It's a 45 because there's something with a square root of 2. As far as the quadrant goes, I maybe should have left a little more space above this part, but we're actually going to be in quadrant 2 because it's negative. So I'm going to draw another version of this triangle up here. It's in quadrant 2, and then this side's going to be square root of 2 over 2. This side's 1, so we've just added a little bit to that picture there. And so now we want to know, where is this located? If I drew this triangle in quadrant 2, it's negative square root of 2 over 2. Where is that? So the question here is, where am I located on the unit circle in terms of radians? And that happens to be at 135 degrees, or in other words, or in radians, 3 pi over 4. Okay? So if this doesn't fit into the range like we're hoping, then we have to do them individually and just do like the compositions that we talked about in the last part of 4.7. So here we are so far. We've got one more left. This last one here is again going to be a little bit of a trick to get this one to work out, but we're going to do sort of the same thing as number 3. We'll notice right off the bat here that the inverse sine does not occupy quadrant 2. It's either 1 or 4. So we're going to have to do these individually. Sine of 2 pi over 3. Well, where is that? 2 pi over 3 in quadrant 2 is going to look like this. 2 pi over 3 is going to have a reference angle of 60 degrees, so that's going to be a 60 right there. And then if we label the triangle, we've got square root of 3 over 2. We've got negative 1/2 on that part, and then 1 right there. Okay, so sine of 2 pi over 3 is going to be opposite over hypotenuse, so that is square root of 3 over 2. That means we rewrite this as sine inverse of square root of 3 over 2. All right, individually speaking here, we're going to now evaluate this inverse trig function. So again, when we evaluate an inverse trig function, we need to decide, first of all, what quadrant is it in. Sine inverse is either going to be in 1 or 4. Since this quantity is positive, that puts it in 1. So we're going to have this one over here, and we are using a 30, 60, 90 triangle. And so we have 1/2 square root of 3 over 2 and 1. And so basically what we're doing now, once we set this one up, once we make sure it looks right, is we're deciding where are we located. This is a 60-degree angle across from the square root of 3 over 2, so that means in radians we're talking about pi over 3. Now I want you to realize something about these last two examples, being that these are the most complicated examples of the group. Notice that even when it didn't work quite right, the triangles, though they were going to end up in a different quadrant, were the same type of triangle. It's just a reflection over one of the axes. So this was a reflection over the x-axis. This was a reflection over the y-axis. We get the same type of triangle, just in a different location if the original angle doesn't fall within the range. Again, to reiterate, if the angle does fall within the correct range, we can just undo them. They're real quick. There's no work to be shown. If it doesn't, that's when we have to draw our pictures. That's when we have to just treat it as individual compositions like we were doing in the previous part of section 4.7. Again, this is tricky stuff. This is probably what I would consider the most difficult stuff of this chapter, maybe even of the year. And so if you have questions about this, please don't hesitate to ask. It is challenging material, but if you're getting this, if this makes sense to you, then you're going to be in really good shape coming up here when we take the test. Thanks for watching and sticking with the whole video. If you did, have a good day.